So the idea of functional programming is that you've got a problem that you're trying to solve with programming, and you're going to break it down into functions. So you're going to keep decomposing it into functional decomposition. So you're going to end up with lots and lots of different functions. Each function is always given input x is always going to produce output fx. All right. So what that means is the functions are going to only need to be tested once, because every function is going to produce the exactly same output given the exact same inputs. So it's just dependent on whether you can use this style of programming to solve the problem that you're trying to solve, because there's two main styles of programming. There's imperative and declarative. So declarative is things like logic for AI, functional programming, and Erlang for more mathematical problems. And then you've got your imperative, which is your sort of procedural, like Fortran and things, and object-oriented, like C# and Java and Python. And it's just deciding on whether this style of programming is right for you. But it's definitely something you should test so you know it exists and you've got the basic knowledge of it. But whether you use it going forwards depends on what the problem is you're trying to solve. So there's sort of a few main reasons why you may lean towards functional programming as a solution instead of what we've typically been practicing so far up to this point. So we'll go through them. So number one, if your programming requirements may be better defined as a series of abstractions based on functions rather than a series of complex steps. So if your problem basically is better when you're doing abstraction, so you're trying to work out what's important, when you're breaking that problem down, if you can break it down into a form where you're breaking it down into different sections which are functions, and that's easier than doing it in a, say, flowchart style form where it's following a series of steps, then functional programming might be the right solution. Number two, broader abstractions can lead to fewer errors during implementation. So if you can break it down into functional programming at that level, it can lead to fewer errors. Because generally speaking, if you've broken a problem down to that level, to the literally just a huge amount of functions you need to make, then generally speaking, the errors and the error checking as you go forward will be easier. Number three, functions can be applied at any level of data abstraction, making them highly reusable within a program. So what that means is just that once you've got a function, because given a set of inputs, it'll always produce the same outputs, is quite a useful thing to have. And you can find that in functional programming, they reuse other areas of code more than you would in the traditional way we've programmed up to this point. Number four, functional code is easier to test and debug as every function cannot have any side effects or only needs testing once. That's, like I said, a function should always do exactly the same job. So given a set of inputs, it will always produce the set of outputs. And for that reason, it's very easy to test and debug. There are no concurrency issues as no data is modified by two threads at the same time. So when you're running functional programming, even if you're doing it over, because remember we've said it's used for distributed processing quite a lot, you don't get concurrency issues because, again, the functions are self-contained. Concurrency is this issue where two people editing something at the same time means that you can get an issue. It's often used for editing database and stuff like that, but in terms of running programs, if you've got one program that's running something which, if it had ran it after, would have affected the other computer, that's a concurrency issue because it's two computers editing that is causing the problem. That's what a concurrency issue is. So you don't generally get that in functional programming. Number six, in a multiprocessor environment, the sequence functions are evaluated in is not critical. So if you've got a multiprocessor, or in a multiprocessor environment, the order in which the functions are evaluated is not important because, again, set of inputs will always produce the set of outputs. So yeah, that's it. Functional programs often use mathematical expressions, so they do lend themselves to writing applications that require lots of calculations. So generally speaking, we don't often have sort of A-level projects that use functional programming, but it's still something you definitely need to be aware of. And if you do choose it as your A-level project, that's absolutely fine. But it's just not typical for the style of problem that most A-level students try to solve.